back, I think it would help if you come down and fill up some of these more expensive ones that we'll let you have without any extra charge. As you noticed, it took quite a little while for the CBS crew to set up this evening, and on that account we're running at least a half an hour late. So I'm going to omit the first half hour of what I was going to say. That will include, it's unfortunate because that will include some of my most shady jokes. But I'll try to take up from that half-hour period. Frank took you back into history quite a little way, but just to go him one better, I'm going to go still farther back. 5,000 years ago, when the invention of writing on clay tablets by the Sumerians first gave the human race an opportunity to make a permanent record of its thoughts and actions, there was already in existence a rather sophisticated science of astronomy. The priests, who were the scientists of those days, were not only familiar with elementary astronomical facts, such as the apparent movements of the sun, moon, and planets, but they had also advanced to the point where they were able to predict eclipses and to calculate the length of the year within about a half hour of its present accepted value. The premises on which these calculations and others of the same kind were made were the fundamentals of the science of that day, in the sense in which I am using the term then. That is, they were the most basic of the relations that were used, the principles that were used by the science of that day. Now, these principles were originally derived by a simple application of what we now call inductive reasoning. That is, they were generalizations from experience. And that is the most reliable method of arriving at scientific principles, fundamental or otherwise. But unfortunately, it's limited by the amount of empirical information that's available and by the extent to which that information has been analyzed. So the result is that an inductive science, such as that of the ancient peoples, has a tendency to fall behind the progress of empirical discovery. And ultimately, it acquires a rather embarrassing accumulation of unsolved problems. Now, that was the situation in Egypt, in Babylonia, and in the Far East about 3,000 years ago. The time was clearly ripe for some new approach, and that was provided by a remarkable group of thinkers that flourished in Greece during the golden age of that country's history. The source of order in the universe, these men said, was mind. And the proper way of arriving at general principles was to apply insight and reasoning. The result of that change in policy was to concentrate attention on the causes of physical phenomena rather than on the phenomena themselves. For the Egyptians saw only the fact that a rock falls if it's released from a height. The Greeks looked for the cause of the fall. Now, they reasoned that everything must have its natural place. So the rock in falling then was merely seeking for its natural place. In this way, by providing an explanation for what happened, they remedied the chief defect of the previous inductive theories. Similarly, they reasoned, as Professor Meyer indicated, that while the Earth is obviously imperfect, the heavens are perfect. And all heavenly motions must then take the perfect form, that of a circle. So the orbits of the planets are undoubtedly circular. Now, observation and experiment were definitely relegated to a secondary position by the Greeks, but they were not disregarded altogether. So when the observation showed that the planetary orbits are not exactly circles, it was recognized that here is an awkward discrepancy that we have to do something about. But one of the strong points of an inventive science, such as that of the Greeks, is that it can easily accommodate new discoveries simply by more invention. So they assumed that the planets move in small circles called epicycles, and these epicycles then move around the main planetary orbit. Then, when further observational refinement disclosed still more discrepancies, those could be taken care of in exactly the same way, merely by adding more epicycles. Now, this Ptolemaic theory of planetary orbits is typical of inventive theories in general. And since we see it in a historical perspective, by taking a look at this Ptolemaic theory, we can get an idea of the general characteristics of inventive theories. The first point that we need to note is that that theory was mathematically correct within the existing observational limits, the then existing limits. That is a general characteristic of all inventive theories because they are invented for that specific purpose. They are specifically designed to fit mathematics that are already known. The second point, significant point, is that that theory, the Ptolemaic theory, was conceptually wrong. The interpretation of the mathematics was wrong. That, again, is a general characteristic. It applies to all inventive theories because of the circumstances under which they're invented. As many observers have pointed out, long-standing problems in science do not continue to exist because of a lack of competence on the part of those who are trying to solve them. Nor do they continue to exist because of a lack of methods by which to go about solving them. They continue to exist because some piece or pieces of information that are essential are missing. In the case of the Ptolemaic theory, there were two such pieces of information. The Greeks did not realize that the planets revolve around the sun rather than around the earth. And they did not know that there is a force of gravitation controlling those movements. Without those two pieces of information, neither the Ptolemaic theory nor any other theory that was invented to explain the mathematics could have been correct. Now, that is a general characteristic of inventive theories. And I'm stressing it at this time because it will be important later on in other connections. If the information is available, if all the essential information is there, then there's no need to invent a theory. Then we can obtain it by inductive means. If the essential information is not there, then any theory we invent cannot be conceptually right. in view of the practically unlimited opportunity for making ad hoc assumptions, that is, adding epicycles, an inventive theory never comes to the fate of the inductive systems of theories. The inventive system may fail to account for a few things at any given time, but there's never the big accumulation that characterizes an inductive theory, an inductive system of theory that's fallen behind the progress of discovery. But the inventive theory, ultimately an inventive system of theories, inventive science I might call it, ultimately encounters a fate of its own. Sooner or later we just have too many epicycles. And in the meantime, the progress of observation and the construction of inductive theories of lower rank is continued, so that ultimately we get to the point where the scope of those theories is broad enough to challenge the prevailing inventive theory. And then the inventive theory goes to the boards. Now that's what happened to the Greek inventive system about 500 years ago. And at that time, the perfection of the heavens and the natural places of objects and the other governing principles that the Greeks had invented were discarded and replaced by other principles that were derived by such men as Kepler and Newton from factual foundations by inductive reasoning. Now, the benefit of the 2,500 years of accumulated scientific knowledge since the demise of the first inductive theories, this new science of Newton and his contemporaries was a vastly improved product. And it scored some very impressive successes. At one time, the practitioners of that science were pretty thoroughly convinced that a knowledge of the entire physical universe was within their grasp. But here again, the inherent weakness of an inductive theory again asserted itself. And Newtonian science found itself faced with a series of problems for which it had no answers. So then the present-day inventive science took over. Now, when an idea or a set of ideas gains general acceptance and becomes a familiar feature of thought, its origins recede from view. And I wouldn't be surprised at what many of you may be reluctant to accept the idea that the basic theories of present-day physics, such as the relativity theory, for example, belong in the same category as the Ptolemaic theory of planetary orbits. But they were all inventive theories. The originators of the present-day theories don't deny that. In fact, they emphasize it. We might even say they glory in it. Einstein told us that pure invention is the only way by which these basic principles can be obtained. And he was highly critical of Newton's attempt to ascertain them inductively. Here's what he said. Newton believed that the basic concepts and laws of his system could be derived from experience. The tremendous practical successes of his doctrines may well have prevented him and the physicists of the 18th and 19th centuries from recognizing the fictitious character of the foundations of his